Hello, we're with Texas Parks and Wildlife here at McKinney Falls State Park, and today we're going to be testing the strength of fishing line.
So today we're using monofilament fishing line, and basically we're going to be testing the tensile strength, which means it's the amount of tension from a force that the line can withstand before it breaks, tears, or stretches. So we'll be conducting an experiment with these two buckets and these weights over here, and we'll be testing two different brands of the same strength. Okay, so come on in. We're going to talk about the materials we're working with today. So here we have some differing weights, and you want to make sure for your experiment that the total amount of weight is greater than your strongest line. Here we have our monofilament fishing lines. We have two 15-pound fishing lines that are of different brands, and two differing weight of fishing lines of the same brand. And here we have our net in which we'll be hanging the buckets from. You do not have to have a net. You can hang it from a tree limb. You can hang it from like a railing of a fence. Anything really works as long as you're able to hang it securely. And here we have our two trusty buckets that we'll be using to work with. Okay, so now we're gonna go ahead and tie the line onto our bucket. This is a 15-pound of our brand B. And I will be using a improved clinch knot for this.
So now that our buckets are securely attached to our pole here, we're going to be testing the tensile strength by adding weight one at a time, leading up to the maximum weight that our 15-pound monofilament fishing line can hold. Beginning with brand A, I'm going to add 5 pounds. And as you can see, our 15-pound fishing line is holding the 5 pounds all right. So we need to take the note of the fact that our bucket does weigh a little bit, and so even if we get up to 15 pounds, it might not hold it because it'll technically be over. So we're going to test and see what happens when we add our 10. It snapped. So we saw what happened with brand A, so now we're going to test brand B in the same way. Beginning by adding the 5 pound, and we can see it's holding up nicely. Now we're going to add the 10. And remember to not drop the weights, but to place them down. Again, it snapped.
So in our experiment, you saw that both lines snapped at their maximum tensile strength, which was 15 pounds. And other things to keep into consideration when you are fishing or teaching fishing is really talking about technique when you're casting, when you're setting the hook on the actual fish, and also some really important things is noting conservation. So you want to make sure that you're using barbless hooks. You want to make sure that you're checking every regulation before you go out fishing. Some other things to note is that you want to use the same bait and tackle that matches your target. And also using lead-free weights, and there's a lot of different stuff out there to look for. Another thing is if you are 17 years or older, or you're teaching someone that's 17 years or older, they have to have at least a Texas fishing license that has the correct endorsements, aka they have to be saltwater or freshwater. Another conservation thing to keep in mind is that monofilament fishing line, the fishing line that we worked with today, can take up to 600 years to break down in the aquatic environment. So please recycle whenever you get the chance, or dispose of the fishing line properly.
Some other important things to note for your experiment is that it must have controls. Our control was that we had two 15-pound weight fishing lines, and they're both new. And that's significant because the age of your line can also weaken it. If it's left in the sun or left in a hot car, or it's just old, it'll naturally be weaker. So you want to make sure that if you're using two different brands or just two different lines, that they're the same age, so get them both brand new. So just like in any scientific experiment, things might not always go exactly as planned, and that happened with us. We first started off using the improved clinch knot for both tying it to the pole and to the bucket, and it came undone when we started adding weight. So we had to use a stronger knot, and so we went up to the Palomar knot, and that worked after that. And you might have the same experience. So if any of your knots come undone when you begin adding weight, make sure you take a note if it's the line breaking or if your knot is coming undone, and you might have to use a stronger knot. Additionally, you don't, like we said earlier, you don't have to use a net. You just need some kind of sturdy pole to attach it to. But you also want to take into account, like if you're using a tree branch, which is an option, that you might need to set something smooth, like maybe a cloth, between the line and the tree branch so that the roughness of the bark isn't snapping the line or contributing to that. So you completed your experiment and maybe snapped some line and had fun, but now we're going to figure out what's the significance of this. Why does the strength of your line matter?
It's really important because when you are actually out fishing, you do want to have the correct strength of line for whatever you want to catch, whether it's a gigantic fish or like a baby minnow. It's really important to have that specific line so that way your line isn't snapping, you're not contributing to pollution in the environment, and you get to keep that big catch when you go home.
Thank you guys for joining us as we did an experiment to test the tensile strength of fishing line, and we'll see you in our next video.